Hi Year 12s. In this video, we will review our exponential and logarithmic laws. These are important to know, both when we are graphing these functions and algebraically solving these equations. If a to the power of x equals a to the power of y, then that implies that our values of x and y are equal. In order to solve some equations, it may be necessary to apply some index laws. Multiplying two numbers with the same base together will cause the powers to be added. For example, a to the m times a to the n will equal a to the m plus n. Dividing two numbers with the same base together will cause the powers to be minused from each other. For example, a to the m divided by a to the n will equal a to the m minus n. When we raise the power to another power, we multiply those powers together. A to the m to the n equals a to the m times n. Finally, any number to the power of 0 equals 1. For an exponential example, let's look at question 5b from the 2013 Exam 1. The question asks us to solve 3 to the power of negative 4x equals 9 to the power of 6 minus x for x. Our first step is to make the base numbers the same. By looking at the equation, we can see that 9 on the right-hand side is the square of 3 on the left-hand side. As such, we can turn the 9 into a 3 by multiplying the existing powers, 6 minus x, by 2. Now that our base numbers are the same, we know that our powers must be equal, so we can drop the base numbers and solve for x. This leaves us with x is equal to negative 6. Now we will look at our logarithmic functions. Log functions are the inverse of exponential functions. It is used to model functions that grow exponentially, and also to change the base of equations. If you hear the term natural log being used, it just means log base e, which you can see now. When solving a log of x, we want to get x on its own. To do this, our log laws tell us that the base of the log becomes the base on the right-hand side, and the log is dropped. Don't worry about understanding the maths behind this, just as long as you can do this move. In this example, log e to the x equals 5 becomes x equals e to the power of 5. Our second example follows the same steps. There are a few logarithmic laws which will help us to perform our algebraic operations. Number 1 is log of m plus log of n is the equivalent of log of m times n. This means that the log of our variables, provided they are to the same base, if added together, is the same as the log of those two multiplied together. Log of m minus log of n is the equivalent of log of m divided by n. This means that the log of our variables, again provided they are to the same base, if minused, is the same as the log of those two divided by each other. Log of 1 over n is the same as log of n to the negative 1, which can be converted to negative log of n. Let's put all of this into practice. Let's look at question 6 from the 2014 Exam 1. Solve log base e of x, take away 3, equals log base e root of x, for x is greater than 0. Our first step is to group the logs onto one side. Then, we can use our second log law from earlier to merge it into one function. Then, we can cancel out the log by rearranging the equation, just as we explained earlier in the video. Then we can cancel down the left-hand side and square both sides to get x equals e to the power of 6. Using our log and exponential rules are not quite as intuitive as solving other equations. Therefore, make sure you practice them a lot to get used to them. Until then, happy studying!